Is my PPT is visible to you? Okay. Thank you. So previously, I have discussed to you about my voice is clear. My voice is clear. Hello. Please answer. Thank you, Vidya. Thank you. I have explained you about objectives of the distribution system protection and why we are going for the protection. Uh, what are the some of the overcurrent protecting devices and over voltage protecting devices also. Okay, so on that fuse is over. Fuse is over. So as I mentioned you, a fuse is an overcurrent device with a current opening fusible member directly by the passing of whenever overcurrent is there, the overcurrent is passing through that particular conductor. Okay, whenever the overcurrent is passing through that conductor, automatically it is going to destroy that particular conductor, when the passage of overcurrent through it in the event of overload or short circuit condition. Okay, in general, a fuse is a type of low resistance resistor that act as overcurrent protection. Okay, in general, I have mentioned you in the PPT. What it states that is nothing but it is a overcurrent protecting device, as well as when circuit is open feasible, when overcurrent is passing on that particular conductor, when overcurrent is passing on that particular conductor, it will do automatically. The conductor is going to heat it and destroy that particular conductor by the breaking of that particular conductor. When it is happened, when overcurrent is there in the event of overload or short circuit condition. All of you remind this. Okay, so the purpose of the fuse is to clear the permanent fault. Okay, the purpose of the fuse is to clear the permanent fault by removing line or detective segment of a line or detective segment of a line or equipment from the system. A fuse is designed to blow with a specific period of time. Okay, a fuse is designed to blow with a specific period of time for a given value of fault current. Okay, each and every device is going to have its own status. So a fuse is also having some limit, okay, to blow out or blow within a specific period of time for a given value of fault current. Okay, the time current characteristics. Okay, when you see the time current characteristics, this is about the time current characteristics of the particular thing. Okay, you will take the time as a y-axis and current as a x-axis. Okay, this is about the characteristics. When time is less, When time is less, automatically you have the higher amount of current is passing. Okay, so whenever time is high, you have the lesser amount of current. Okay, this is going to work when time is high. Okay, when time is high is there, at this time only fuse is going to have the lesser amount of current. When higher amount of current is there, within a fraction of seconds within a fraction of seconds, fuse may get have that particular thing. Okay, the time versus current characteristics of a fuse is going to represent it with a two curves. This is a two curves. Okay, this is a one curve, and another one is I am drawing here. Same same connection, same things. Okay, so first one is, this one is minimum melting curve. Okay, minimum melting curve, why means minimum amount of time versus current required to melt the fuse link. Okay, this is a minimum amount of curve, minimum amount of time it should take, minimum melting curve, and this is about the total clearing curve. Okay, so fuse is going to have two operations. One is, first of all, you need to melt that particular fuse, and you need to clear that particular fault. Okay, these two, when the fault is there, automatically you have to you have to detect that, and you have to heat that particular material, that particular conducting material, and within a fraction of seconds. Why I am going to have a minimum melting curve? Okay, minimum melting curve of a fuse. Okay, minimum melting curve of a fuse, this is a below run is a minimum melting curve of a fuse. Okay, all of you remind, when 100% rated value is there. Okay, it is designed, fuse is designed to the 5 amps rated. Fuse is designed to the 5 amps rated means, always remember, minimum melting curve you have to draw with a 4 amps rate. Okay, minimum amount of time it should require, so minimum amount of current it should require. So the minimum melting curve, this is about the minimum melting curve, mmc. I will write mmc. Okay, mmc, clear. And the here mmc is nothing but minimum melting curve. Okay, and here tcc, total clearing curve. Okay, you need to have two curves, two characteristics. You need to have two curves. First, when you take two types of switches, when you take two types of protecting devices, total clearing curve is having maximum amount of time. See here, maximum amount of time is required here. Okay, when you extend this particular thing, you will have a maximum amount of extend time, maximum amount of time it should require. See here, when you compared here, okay, it should take to clear that fault is also. See, you draw the parallel lines. Here at a particular ceiling current. Okay, for the same current. Okay, current versus minimum melting point is this. Melting point is this. Okay, melting point is, sorry, melting point is this. Okay, clearing point is this. Okay, clearing point is having higher value, melting point is having lower value. All of you remind this. Okay, so melting point is this, this is melting point, this is clearing point. Okay, and this curve you may draw between the, okay, this curve you may draw between minimum amount of current, minimum time versus current required to melt the fuse. Melt the fuse. Okay, and here this TCC you will have maximum amount of current. Okay, maximum amount of current maximum amount of time versus, okay, Vs is nothing but the versus, okay, versus the current required to melt the fuse. Right, to melt the fuse link and same current, na, see here, same amount of current and extinguish. Okay, extinguish or so you will have a spark amount of thing. Okay, this is about you have some contact. If that arc is nothing but a contact between the two conductors, heated material. Okay, this is about the two curves, PCC as well as NMC. In general, PCC will give the coordination. PCC will give the coordination. All of you remember this. Okay, can I go for the next topic? Hello, are you understood? Hello, are you understood? Hello, is it clear? I am asking once again, is it clear? Okay, thank you. Thank you, Vamsi, all the people. So I have these two things, minimum melting curve as well as total clearing. Okay, things, and fuse is going to design. Okay, fuse designed to be used above. Okay, in the distribution system, fuse is going to design to be used above 600 volts. Okay, 600 volts, more than 600 volts are categorized for the, okay, 5 amps, 6 amps are the normal amount of things. Okay, more than 600 volts are there means, okay, more than 600 volts are there for the distribution system. For the distribution system means automatically this type of fuses are called as fuse cutouts. Okay, fuse cutouts. Okay, fuse cutouts are power fuses more than 600 volts. More than fuses are designed more than 600 volts means those fuses are called as a power fuses or fuse cutouts. Okay, all of you remind this. This is a great question. Okay, and always remember these fuse cutouts. These fuse cutouts are the most common type of protecting device. Okay, this power fuses are mainly used for the primary distribution system. Why means which is having the 11 kV amount of power, amount of power. So you need to use more amount of rate. So you can have a two names, fuse cutouts or power fuses. Okay, fuse cutouts as well as power fuses. Okay, you need to know about this. In this cutouts, you need to remind one thing. Okay, the melting of the fuse link causes heating. Okay, in general normal fuses is also having this particular type of heating of the fiber fuse. Okay, heating of the fiber fuse which produces with which produces deionizing gases, deionizing gases to extinguish arc. Okay, whenever you are using 600 volts type of rated type of fuse, which is a fiber fuse. Okay, fiber fuse is going to use, whenever you are using the fiber fuse, automatically which produces a gases, deionized gases, gases to extinguish arc. Already arc is there, so whenever you have a arc, you are going to produce a deionizing gases in the fiber fuses. Okay, this particular type is a type of expulsion type of thing. Okay, expulsion type of thing, expulsion type of fuse cutouts I have means automatically. See, expulsion type of things are there nothing but the fiber. When you use the fiber, you have a expulsion type of fuses. Okay, you have different types of categories of the fuses are there. So whenever you have the different types of categories are there, whenever you have the different types of categories are there, the first one is expulsion. Why means it is going to give some deionizing gases when the arc is forming. When the arc is forming, when we are going to give the, when we are going to use this particular type of fuse in the highly rated particular type of things, automatically you are going to use more amount of rated amount of fuse. Okay, the second one is open fuse cutouts. Open fuse cutouts means normal fuses, normal fuses. And third one is open loop fuse cutouts. These are all are different types of fuses you have used for the, you have used for the distribution system. Okay, so the ratings of the ratings of the distribution fuse cutouts, distribution fuse cutouts are based on the, based on the continuous current carrying, based on the current continuous current carrying capacity and capacity of the voltage, nominal voltage, as well as maximum design voltage, as well as interrupting capacity. Okay, I told you expulsion type, I told you open link, open fuse type, open link type of thing. These three type of fuses I have in general for the distribution system. In general, these three type of things are there. How we are going to classify this? Nothing but, okay, depending on the continuous current carrying capacity, depending on the continuous current carrying capacity, as well as nominal voltages and maximum designed voltages. Okay, maximum amount of voltages, maximum amount of voltages and interrupting capacity. Okay, as well as there are fuse cutouts. The selection of the fuse cutouts, the selection of the fuse cutouts are based on the following rules are there for that. Okay, if the, if the type of the system, if the type of the system for which their selected lines are overhead, if the type of the system is, if the type of the distribution system is, okay, you have a secondary distribution system. In general, you will use the open link type of fuse cutout, open link type of fuse cutout. In generally, the type of the system for which they are selected like overhead or underhead, overhead or underhead, underhead is nothing but a underground. Okay, why I am saying underhead means overhead, overhead means normally by the seeing of the outside of the connection. Okay, underground you have, or delta to star connections are there. Okay, these are all are there, as well as the fuse cutouts more than 600 volts are used for the system voltage for which they are selected. Okay, and the maximum available fault current, the maximum available fault current, this is also a very important thing. Okay, the maximum available fault current, the maximum available, the fuse cutout may be decided with the maximum available fault current. Okay, so it is allowing 5 amps of current, so you can use that particular type of thing. Even the fault also you are going to get that particular power. So you may have a more amount of damage at the load side. Okay, you may have a more amount of damage at the load side. You need to remind this. Okay, as well as the system voltage for for which they are selected. Okay, the system voltage is also a main consideration. Current you have, voltage you have, as well as maximum amount of fault current also. Maximum amount of fault current also. Whenever loads are increasing, automatically reactance, the effect of the load is going to give, you know about that. The effect of the load, particular load is affected to the source side. Okay, source is affected by the reactance effect. Okay, so there is a ratio of the x by r. Okay, x by r at the point of application, as well as at the point of the tapping also. You need to know about the x by r ratio. Depending on these things, fuse fuse cutouts are going to be selected. Depending on these things, fuse cutouts are to be selected. As well as power fuses are employed. Okay, power fuses are employed where the system voltage is, 34.5 kV or higher. The interrupting requirements are greater than the available fuse cutout ratings. Okay, so always remind you that power fuses are above to the 600 volts. In general, you have 34.5 kV amount of system voltage there. Automatically, you can use for the power fuses. Okay, so these are all about the power fuses, and they are power fuses are okay, which is having special things. Okay, first one is that and large range of current carrying capacity. Okay, why we are going to use this for fuses, you need to know about this. Okay, so high interrupting voltage ratings, as well as large range of third one is these power fuses are not only applicable for the distribution, it is also applicable for the sub-transmission as well as transmission. Why means, which is a high rated amount of uses, which is a high rated amount of uses. That's why we are going for the power fuses in the sub-transmission as well as sub-trans. Okay, this is about the fuses. As well as it is designed and built usually. It is designed and built usually at the substation, and maintaining rather than the poles as well as cross arm maintaining. Okay, so substation, when substation is going out, or one power fuses, a bundled amount of power fuses are for the sending end of the transfer. One means whenever fault is there, the particular amount of different types of fuses, as well as fuses used for the distribution system, and in general, how you represent the fuse, so I'll draw that. For the distribution system, sorry, this is the fuse representation. Okay, this is the fuse representation in the distribution system. system. Okay, in general, you know, most of the people are knowing about the most of the people are knowing about this. Okay, can I go for the next topic of this? Up to now you have discussed about the fuse and applications and can I go for the next topic? Is it clear? I am once again asking, is it clear? Again, I am asking, can I repeat it? Hello, can I repeat it once again? Uh, it is trying. So whenever I have this type of high rated amount of high rated amount of fuses are there. Okay. So above to be fuses designed above 600 volts are categorized as a distribution cutouts. Distribution cutouts. So distribution cutouts are nothing but in general, in generally in generally we will have a fuse distribution cutouts and fuse cutouts and power fuses. Okay, in fuse cutouts there are some three categories: expulsion type, as well as expulsion type. I have expulsion type of distribution cutouts are mostly used for the mostly used for the hello. I think it's okay now. I'll update. Hello, disturbance. Finish. Are you getting any disturbance? Just hello. Is it okay, Nana? Is my screen is visible to you? Oh, okay, Nana. So I'll explain this. So whenever I have this particular type of thing, so you have a three different types of fuse cutouts. One is expulsion type, and open fuse cutout and open link fuse cutouts. Okay, open fuse cutouts and open link cutouts are open fuse cutouts and open link cutouts are used for the overhead type of thing, are used the open overhead type of thing, as well as this particular expulsion type you may used for the underground switches. Okay, especially underground for the underground distribution system, this expulsion type is going to use. Okay, as well as in the expulsion type we are going to use fiber fuse. Okay, we are going to use fiber fuse which produces deionizing gases to extinguish the arc. Okay, fuse operating conditions, you know. Okay, when the severe amount of fault is there, when the severe amount of fault is there, automatically you are going to have a you are going to have a major problem. Okay, so the ratings of the distribution fuses cutouts are based on the continuous current carrying capacity and normal and maximum amount of maximum design voltages and interrupting capacity. All of you remind. Okay, the rating of the distribution fuses cutouts are based on continuous current carrying capacity, nominal as well as nominal and maximum design voltages and interrupting voltages. So this is about the one, and the fuse cutouts are selected based on the following points. Okay, I am going to say about the following points. Okay, those following points are: this is going to select it when undergrounded systems are available, when higher amount of voltages are available, when X by R ratio is high, when X by R ratio is high, maximum amount of fault current is there, maximum amount of fault current is there. At that time only, at that time only, you are going to use the power fuses. Okay, as well as in the standards above to the 600 volts, especially in the subtransmission level also. In the subtransmission level above to the 34.5 kV rating, okay, like 33 kV or 11 kV, like 33 kV or 11 kV, you may use for the system, you may use for the system. So this is about the particular thing. And the to have the higher interrupting requirements and greater than the available fuse cutout ratings, okay, fuse cutout ratings, okay, you need to have special facilities of this. Okay, first one is first one is first one is higher interrupting ratings. Okay, higher amount of current I have means you need to interrupt that. Okay, you need to interrupt that, as well as larger range of continuous current ratings, larger range of continuous current ratings. Okay, very nice. This is also a one thing. Okay, and third one is it is applicable not only for it is applicable for not only for not only for the distribution system, and it is also applicable for the sub transmission as well as transmission system. Fourth one is it is also designed to design and built usually for the substation uh, substation mounting rather than the pole and cross mounting. Okay, so this is about the particular type of fuse. Can I go for the next topic of your subject? Hello, I am using my phone, Nana. Actually it is a problem. Okay, repeat, sir. Very nice, thank you. See, in the fuses more than 600 volts are there. Okay, in the fuses higher amount of rating fuses are there. Okay, those higher amount of rating fuses we will call it as a fuse cutouts or power fuses. Okay, power fuses. Okay, those fuses are classified into three types. Okay, one is ex expulsion type. In the expulsion type also you have classification. Okay, expulsion type, that expulsion type is having some classification: exclusive type, open fuse type, and open link fuse cutouts. Okay, so I have these three. Most of the most of the expulsion type of thing, why you have the expulsion? So whenever you have a higher amount of current is there, okay, you have some arc is going to form between the conductor. Okay, so that arc is going to provide expulsion type of gases. That's why it is called as expulsion. Okay, in the expulsion type also you have some subcategories. Okay, like exclusive type, open fuse type, and open link type. Okay, these three are there. Okay, so in the expulsion type, okay, always remember when you have 600 volts, when you have 600 volts and above that, you have the power fuses in general. Okay, and these ratings of the distribution fuse cutouts are based on the, okay, based on 4 points. One thing, con- continuous current carrying capacity, nominal and maximum design voltages, nominal voltage and maximum designed voltage, and interrupting voltage. Okay, interrupting voltage capacity. First is current. Second one is nominal voltage, base voltage, as well as maximum amount of voltage. How at which level you need to go for that. Okay, at which level you need to go for that. That is also you need to see. And next one is interrupting capacity. At which time you need to interrupt. At a fault condition, you need to interrupt that. Okay, this is about the ratings of the different fuse cutouts. Okay, when high amount of currents are there, fuse cutouts. How you design means, how you are going to select means, these are the four things. First is first is what? First is what? Tell me. Current carrying capacity, nominal voltage, nominal volt. Hello, Indu. I think PPT not visible. PPT not visible. Okay, I'll show her along with this. Switch camera. Is it okay? PPT screen is visible. Blur. See what I am doing. I am at a time I am using the both. See, I am facing the here. The here is the problem. Is browsing. Yeah. Are you getting here?
Hello?
Hello?
Hello? Are you getting my points? Hello? Is it okay? Yeah. Okay. Is it okay? Is it okay, Rashid? PPT. I can hear the voice. Is my screen is visible? Okay. I am facing a network problem. Okay. Clear? So whenever I have a particular this particular type of thing, you have this particular type of thing. Okay. First one is to opt that particular to opt that particular rating type of thing purpose. To opt that particular rating type of purpose, you need to go for the four things. One is continuous current carrying capacity, nominal voltage, maximum design voltage, as well as fourth one is the interrupting capacity. Okay, these four things you need to fix for the
rating of the fuse. Okay, and for the selecting of the fuse purpose, for the selecting of the fuse purpose, for the selecting of the fuse purpose, okay, you need to know about, okay, whether the system is overhead or underground, or whether the system is having the delta connection or star connection, and whether the system is having whether the system is having specific type of voltages, okay, and maximum available fault current, okay, maximum allowable fault current, sorry, maximum allowable current, fault current you need to go, and x by r ratio also you need to see whether you are using, whether you are using a different types of loads are there which is affecting the sending end side, which is affecting the sending end side. That's why I am going to use this particular type of thing. As well as power fuses are employed, where the system voltage is, where the system voltage is, where the system voltage is 34.5 kV, okay, or higher the interrupting requirements are greater than the available fuse cutout ratings, okay, above to the 600 volts in the subtransmission level 34.5 kV, okay. So where you have the more amount of rating, you can use this power fuses, okay, this power fuses. And there are different form of there are how you select the ratings of this particular thing is nothing but, okay, the rating is capable for the high high interrupting and large range of current carrying ratings, okay, large range of current carrying ratings, as well as it also applicable for, it also applicable not only for the distribution as well as transmission as well as sub-transmission levels. Next one is, it is designed, it is designed for the, it is designed to build for the substation mounting rather than the pole and cross arm mounting, okay, pole and cross arm mounting, okay. This is about the particular system, okay, particular system, fuse and fuse ratings and fuse amount of thing, okay. Can I go for the next topic or repeat it? Hello, please mention in the chat window. Repeat. Very nice. Thank you, Rajashri. See, fuse. Tell me, fuse is a one conductor. Okay. Fuse is a overcurrent protecting device. Okay. Overcurrent protecting device, and which is having a withstand capacity, and circuit opening fusible member directly heated, okay, directly heated, as well as directly heated, and destroyed by the passage of, overcurrent through it, in the event of overload or short circuit, So the purpose of fuse is to clear the permanent faults, by removing of the defective segments of a line or equipment from the system. Okay, what I mentioned on the PPT is I have briefly enhanced that, and a fuse is designed to blow. With a specified time, for a given value of the fault current. Okay, so you know about the time current characteristics. This is about the time current characteristics, okay, of a fuse. Okay, this time current characteristics are having the two. One is minimum melting curve, another one is total clearing curve. Minimum melting curve of a fuse is a plot of minimum time versus the current required to melt the fuse link. Okay, there are two operations. One is melting of the fuse conductor, as well as to clearing of that fault also you need to know. Okay, as well as the total clearing curve is nothing but just above to that you will get, just above to that you will get this total clearing curve is a plot of the maximum time versus current required to melt the fuse link as well as extinguish arc. Okay, see here, same required to fuse melt and extinguish arc also. Okay, this is about the total clearing curve, and the representation of fuse is like this. Okay, the representation of fuse is like this. Okay, this is about the representation. This is about the representation of the fuse. Okay, this is about the representation of the fuse. So, fuse is designed for the 600 volts. Fuse is designed to be used above 600 volts are categorized as distribution cutouts. Distribution cutouts, also called as fuse cutouts, are power fuses. Okay, this power fuses also having a name of expulsion type of cutouts. Expulsion, why we are going to have the expulsion type is nothing but which is going to give some amount of gases, okay, especially in underground distribution system. In underground distribution system you may use this type of thing. Okay, in these cutouts, in this expression power cutouts, the melting of the fuse link causes heating of the fiber fuse. Okay, in general, in the underground system you will use the fiber as a material. Okay, fiber fuses are there. Okay, fiber fuse which produces deionizing gases to extinguish arc. Okay, and this expulsion type of cutouts are classified classified according to their external appearances and operational methods. Okay, so those classifications are exclosed fuse cutouts plus exclosed fuse cutouts, as well as open fuse cutouts and open link fuse cutouts. Open fuse cutouts and open link fuse cutouts are used for the overhead system. In the outside of the in the outside of the world, we were going to use open fuse cutouts and open link cutouts. Okay, and exclosed fuse cutouts are used for the only underground type of thing. Okay, and the rating distribution fuses cutouts are based on, okay, the rating of the particular fuse cutouts or power fuses are selected by four things. One is one is first one is continuous current carrying capacity. Second one is nominal voltage. Third one is maximum design voltage. Fourth one is interrupting capacity. Okay, fourth one is interrupting voltage. And these fuse cutouts are selected based on the, okay, okay, rating selection is different and the fuse selection is different. The main fuse selection is different. Okay, so the main fuse selection is based on the overhead or underhead connection or system voltage to be selected or maximum available current, maximum allowed, so you need to know. Okay, fuse rating selection is different, fuse selection is different. All of you remind this. Fuse rating selection purpose, continuous current carrying capacity you need to see, nominal voltage you need to see, as well as maximum design voltage you need to see, and interrupting capacity you need to see. Okay, and fuse selection also, okay, fuse selection is depending on the which type of system you are using, and system
system voltage you need to you need to know, okay, depending on the system voltage and depending on the maximum available fault current, depending on the maximum available fault current and X by R ratio you need to select. This is about the different types of fuse selection, okay. And power fuses are employed where the system voltage is where the system voltage is above to the 34.5 kilowatts kilovolts or not watts, 34.5 kilowatts or higher the interrupting requirements or greater than the available fuse current ratings, okay. So whenever you have the 34.5 volts or higher, you can use this particular type of things, this particular power fusing type of things, okay. And there are different form of different there are different types of things are available, okay. That things are nothing but higher interrupting ratings as well as larger range of current carrying capacity. In general I am saying, okay, for the power fuses in general we have these other things, high interrupting ratings, okay. High means we will go for the higher rating, okay. We will go for the higher rating as well as large range of current, continuous current ratings. And third one, it may use for the sub transmission as well as transmission system, okay. And fourth one is it is designed and built usually for the substation mounting, okay. To build a substation purpose you can have this particular type of fuses, okay. Or when you connect a one power fuse there on a particular substation, you can have the particular thing rather than the pole mounting or cross arm mounting, okay. Whenever you are going for the pole mounting or arc mounting, instead of using this you can use a substation mounting when you use the power type of fuses, okay. This is about the fuse. Are you understanding? Hello, thank you Rajeshri, okay. And fuse ratings, so fuse applications are fuse applications and advantage in the distribution system you are going to use, in the transmission system you are going to use, in the generation system also. After the generation, to transmit the power from the generation system also you are going to use the fuses, higher amount of it like power fuses, okay. And fuse advantages are nothing but cheapest one, okay. Only one conductor is needed and no maintenance. Within a fraction of seconds you can replace that particular conductor also. And for the lower amount of thing, for the lower rated amount of thing, there is no way of providing the smoke or noise. But if we have higher amount of rated, we have a short circuit current problem with the noise as well as smoke, okay. Whenever you have a lesser amount of power is there, automatically which is going to break heavy short circuit current without noise and smoke, okay. This is about the advantages of the fuse. And fuse disadvantages is, okay, fuse is considerable time versus here vs, okay, considerable time versus required in the removing and replacing a fuse after the operation, okay. It requires the more amount of time, it requires some amount of time is there, okay. And current time characteristics of a fuse can not be correlated with the other protected operators, okay. When you are using two amount of fuses, okay, at the sending end I am using one fuse, at the receiving end I am using another fuse, okay. In between that Okay, there is no coordination, there is no correlated between that. Okay, there is no correlated between that. Okay, up to here I am going to I am going for the views. If you have any certain type of comments or any certain type of doubts, you can reach it out me on phone. My phone number is 9949360215, or you can mail me. I'll clear it. Okay, by tomorrow or by Monday I'll start the circuit breaker concept. Okay, so before leaving this particular thing, okay, circuit breaker, what is circuit breaker? Okay, circuit breakers are, it is a equipment, protecting the equipment. Circuit breakers are, see, this time, this is a closing of your class, Nana. Okay, few of the members are admitting it's their headache. How I can admit? You know about my problem. Okay, most of the people are sitting here. See, are you seeing my screen? Most of the people are, by 12 o'clock they are logging. They are doing login. I will not give attendance to Mahinder. Why means he left. So this is the closure of your class. Before going to closure, circuit breaker is a device, protecting device, which is a automatic interrupting devices uh, when when it is capable of breaking, and reclosing a circuit under all conditions. Okay, when faulted conditions are there, when normal conditions are there, it is having a capability, for the breaking as well as reclosing the switches by the using of relay. Okay, so the primary task of a circuit breaker is to extinguish the, okay, is to extinguish the arc that develops due to separation of its contacts in an arc extinguished media, okay. So by the help of the relays and by the help of PTs and CTs, it will detect and it will open and it will uh, it will breaking. The system is going to break and reclosing done by the system. Okay. Thank you one and all. Um, Thank you. See, you are seeing my screen. Till few other people are going to log in. If you maintain these type of things, I will not give attendance to Sai Kiran also. If thank you everyone. I got your attendance. You don't want to post your roll numbers also from now onwards. I got your attendance. Thank you very much.